All right, off we go. All right, so we have an alpha and an A and a B. So first thing I like to do is make a rough sketch of this. So let's say I'm going to put B along the bottom. So that's going to be my 242.8. And then alpha can go over here, 43 degrees. So let's see. That's around 45-ish. So if I go a little lower, maybe that's around 43. And then this side needs to be, let's see, 180 versus 240. That's a rough guess, right about here. So I'm going to guess this. Oh, no, A would be on the other side, wouldn't it? Sorry. So that was just a bad guess. Let's do that again. A is opposite. So I'm just going to draw a big line here because I'm not sure how big this one's going to be. Let's say that's about 43 degrees. And then somewhere off of the end of B here, I've got to come up with what I think is about 184. So somewhere in here-ish, it's less than 242. All right, I'm just going to rough it in there for now. So if this is my alpha at 43.1 degrees, then I'm guessing this is about A at 184.2. So labeling some other stuff, if side B is down here, then beta has to go up there, which leaves this one for gamma, doing Greek letters, and that means this would be side C over there. And since I have an angle and an opposite side, I'm thinking law of sines is probably a good way to go on this one. If I were doing law of cosines, then I'm probably looking for two sides with an angle between them is a thing for cosines. So then I'm going to use, let's see, I'm trying to find here, I'm going to start looking for beta. So I'm going to say sine of beta divided by side B, 242.8, is equal to sine of alpha, which is 43.1. And don't forget to label the degrees just to remind ourselves to make sure we're in the right mode on the calculator, over 184.2. And so to solve this, I just need to multiply up that 242. Well, not just, but that's a good start. So I've got sine of beta is equal to 242.8 times the sine of 43.1 degrees over 184.2. And the only exact answer we can get is by using the inverse or arc sine. So then beta will be equal, I'm going to write it as sine inverse of that. So let's plug that into our calculator right away. Desmos graph. All right, so I'm going to switch the mode here to degrees. And then I want the inverse or arc sine of 242.8 times sine of 43.1, thing, I'll double check that, divided by 280, no, 242. 184. Oh, 184, other one, yes, thank you. 4.2. All right, so it looks like we're getting around 64 degrees, 64.24-ish. And again, we can always hang on to more decimal places there. So I'm just going to add that to my notes. So I think beta is approximately 64 point, what was it again? 4. Or am I hallucinating? 2-4, yeah.
So I have a question.
Yes.
When you plug it into Desmos, I guess this is probably where I am going about it wrong. Is I put in the 242.8 sine times 43.1 degrees over 184.2.
Yeah.
And then I use that decimal and use the arc sine.
Then do the arc sine. So then it depends on how you do it in Desmos. So if you calculate this first and then round it and then plug it into the arc sine, then you're introducing more rounding error. So by the end of the problem, the other answers could be significantly off. On paper, they're not going to be enough off, but if like when we were using the computer generated homework assignments, if you did like 3 roundings in a row, by your 4th answer, the computer's going to say, oh, you're too far off in the tenths or hundredths.
Okay,
So you want to be careful.
I got 61.25 because of the generated homework, I, did 4 decimal places.
So my usual thing is if I can avoid rounding as much as possible, I do.
Okay.
So in this case, for example, I think it's better to not calculate this separate. If you are using Desmos and you do that, you could always name it and reuse it.
Okay.
Right? So for example, if I just cut that out for a second, just get rid of this. Suppose I calculate that first and call it something like A. Oops, that was it.
It's
I can't copy paste it. Anyway. Okay. So again, since Desmos, you can name things, I would recommend naming.
Okay.
So I can put that back in. A equals, it was again the 242.8 sine of 43.1 over 184.2.
Yeah.
Okay.
I guess I did the whole thing over.
Yeah, it turns out it works out the same way.
Okay.
Either way. You should get the same answer. And then from there, I can say, all right, now I want the inverse sine of the thing above I called A, so then I don't have to worry about rounding error. So again, sorry, this is blocking me. I called the first calculation A, so then I can just reuse it. And if I needed to reuse this number here, I could just call it B, for example. And again, mode is important. So if you're not in the right mode, you'll get a different answer, right? If I switch this to radians, then my stuff gets messed up. Back to degrees. All right. All right. So next, now my picture is very rough. I didn't measure anything. I was just guessing. So does my picture look like beta equals 64? No, my beta looks more like 90, but again, this isn't an accurate sketch. It's just rough. But I can continue. So I have a value for beta, so I can just subtract to get gamma. So then I'm going to take 180 minus, let's try that again, the 43.1 I was given, minus, and I named the angle above B, so I'm just going to say minus B, so I don't have to worry about rounding. So to 2 decimal places, it's going to be around 72.66. And anytime you use your calculator, you should write on paper what you did. So I'm going to say gamma equals 180 minus 43.1 minus what I calculated for beta. And that is approximately, I forgot, 72.66-ish. All right, so I've got beta, I've got alpha. Now I can, I've got beta and gamma. Now I can go find C. And I'm just going to stick with the law of sines to find C. I could use law of cosines, but that's more complicated. So to find C, I'm going to flip and say C over the sine of gamma. And I'm just going to call it gamma because I'm going to use the number in Desmos, so I don't have to worry about rounding. is equal to, and what should I set it equal to? I would use
Yeah.
alpha because that was given, right? Beta, I've possibly introduced error, so I wouldn't do that. And since I flipped it, I'm gonna have to write it as 184.2 over the sine of 43.1 degrees. And I like it flipped like this because then I know the sine of gamma, so I can just multiply that up to the other side to get my answer for C. And I'm going to use the calculator's value I have already stored in there. So I don't have to worry about rounding. So I'm using Desmos as a worksheet, an interactive worksheet. So I should name this something. Let's call it G for gamma. All right, so then I've got my 184.2, and I'm multiplying that by the sine of gamma, in this case, the sine of G. I'm dividing that by the sine of alpha. Alpha was 43.1. And Desmos holds on to, my guess is a lot of decimal places. So there's probably no rounding error in the first 10 decimals here. So I'm getting that side C should be about 257.33. And again, I can use Desmos to avoid rounding error by naming things, which is nice. It's a good thing to get into. If any of you are going to engineering in the future, interactive tools like this are super helpful to avoid rounding error. That can later be a problem. Like I tell you guys, I grew up in Rhode Island, and they were building a new bridge across the harbor, and they were building from the east side, and they were building from the west side, and they were going to meet, and they didn't quite meet. There was a little rounding error that they missed, and so they had to adjust a foot of height and left to right to try and get the two pieces to fit together. It was a challenge. So precision when we can. All right, so 180, so 257.33-ish. So C is about 257.33-ish. Check, wrote it correctly, I think so. All right, am I done? I don't know. So I think I've got all the missing pieces here, but could this be one of those cases where there's more than one answer? And it could be.
I still don't understand.
Yeah.
When there can be another answer?
There is another.
Yeah, okay, so I'm gonna re-sketch this information and try and figure out if there is possibly another one. So let's start over to check that. But I'm pretty sure I just built one triangle that works. Tool. Let's re-sketch and contemplate if there's another one.
Before you move on to that, can I ask a question?
Yeah.
When you were trying to find the angle for C and you subtracted the initial alpha value.
Yeah.
From 180, is there a difference if I were to add the alpha and the
Beta and then subtract.
beta and then subtract?
Same
No,
idea.
okay,
Yeah.
I just want to make sure.
Yeah, that should give you the same result. Good question. Okay, so let's see. I have an angle and two sides. So I'm just going to sketch this different than I did before to see if that helps. So I'm going to make a baseline. And then from that baseline, I'm going to estimate 43-ish degrees. So, that's 90, that's 45-ish. So 43 is a little bit less there. Okay. So let's label what I have so far. So that's alpha is 43.1 degrees. This time I'm going to put B up here. So I'm going to say this is my B equals 242.8. And I'm wondering if I draw it a little bit different, well, I might see another option. I mentioned in class the other day that in a situation where you have an angle and a side and another side, sometimes, depending on this altitude right here, this height, if the other side you're given is in between the height and the length of this side right here, then you can get two possible triangles. So if the other side I'm given happens to be long enough so that it could fit here or there, then I can get two different triangles. All right, so does this happen here? Well, to see that, I guess I need to figure out what is that height right? So to figure out that height, it's going to be related to, it is opposite the angle I have here. Trouble with my pen. It's opposite the angle I have here, and this would be the hypotenuse. So then the sine of 43.1 degrees is equal to the height divided by the hypotenuse of 242.8. So that means the height must be 242.8 times the sine of 43.1 degrees. So for sure, I can see that my other side A is smaller than side B. If it's also bigger than the height, then that means I have two possible triangles to make. All right, calculator. Let's check. What is 242.8 times the sine of 43.1? 165. My other length is longer than 165 and smaller than 242. So that means there are two options for this triangle. Which one did we just find? Okay, let's see. So I'm going to, back here, I found that beta was about 64 degrees in my first attempt. Side B is over here, so that means this is the beta I found right there. That does look around 64 degrees. It's a particular sketch. The other option for the angle would come from, a highlighter, this triangle right here. And in that triangle right here, I have a different beta. Beta would be this angle right here. Let's call that one beta 2. Would you agree that's much bigger than 64 degrees? Okay. What's the relationship between beta 1 and beta 2? Well, because these blue lines right here are the same length, that means this triangle right here is an isosceles triangle, which means this angle right here is also the same as beta 1, which is that one right there. So the other angle, beta 2, is going to be 180 minus beta 1. Always going to work that way. If there's another one, your other angle is going to be 180 minus whatever beta 1 was. So that's going to be my second triangle. So it turns out there are two triangles in this case. Let's calculate the rest of that one. Don't worry, I miss this all the time too. The book gave an example, and I'm looking at the example like there's no way there's another triangle. It's physically impossible. And then later I thought to draw what I first drew upside down. It's like, oh shit, there's the other one. It happens. All right, so off to my calculator. So let's see. All right, so I called it B here, was the first beta I found. So I'm gonna have to come up with a new letter for this one. We're gonna call it, well, there's a side C, I don't use C. We haven't used D. Oh yeah, capitals are different. Yeah, okay. Desmos is case sensitive. So I could say capital B is 180 minus lowercase b. So my other angle is about 115.76. Oops. Okay. Now that I have that, there's also another gamma that goes with it. And we can find that one. So I'm going to have a gamma 2, which is going to be 180 minus the 43.1 minus my beta 2 here. All right, so again, off to my calculator worksheets. So let's say I call the other one little gamma, so this one can be big G equals 180 minus 43.1 minus my big B above. So 21.14-ish. Degrees, don't forget to label your degrees. And I'm going to have a new side C down there. Right, so my gamma, my new gamma 2 is up there. So we got to whip out the law of sines again to figure that one out. So let's call it side C2 divided by sine, and I'm just going to call it gamma 2 here. I have it in my calculator. It's going to be equal to side A, which is 184.2, over the sine of 43.1 degrees. And again, I'm writing it upside down, so I only have to multiply that sine up to get an answer. And now it's calculator time.
That makes sense, because I've been,
Yeah, so again, generally, I almost always have to draw pictures to solve these problems. And on some problems, I got to draw more than one picture to figure
well, I
it out.
just mean the placement of where you put the sign.
Oh,
Because
why I wrote it that way?
Yeah, because I have been like, okay, well, how,
Yeah,
What?
if you all, so when I'm missing an angle, the signs go on top. If I'm missing a side, I put the sides on top and the signs below.
okay,
It's easier to solve that way.
Oh.
One, 2 less steps, which is kind of nice. Okay.
Well, even if it is the other way, if you do the cross multiplication.
Yeah, cross multiply and divide, it's still going to give you the same answer. It's just, yeah, an extra
I
step.
just seem to place them backwards, so then when I'm looking at it, I seem to get confused with myself and what I'm doing. That's what I'm for. Wait,
And here, I'm not going to type the approximation. I'm just going to put my capital G for my second gamma, is how I labeled it there. And then I have to divide that by the sine of 43.1. So I should find my other side now is 97.24-ish. And again, my picture's not perfectly to scale. It's rough, but not as rough as my first try. If my previous answer for C was, how big? It's hiding there at the bottom, 257.3. So if this side here is 257.3, it seems reasonable that that's around 100 in my rough sketch. And like I mentioned, I can't just draw one triangle and come up with both versions if there are two. I usually have to redraw to figure it out because it gets too messy. That was my first try using law of sines. Redrawing it, I found there was a second version.
could you have done it by using the law of cosines? Initially,
Let's think about that. All right, I'm gonna put that in a new video though. This is getting kind of long.